fastest any human has ever travelled is 39,897 km per hour when Apollo 10 re-entered the Earth's atmosphere after they had orbited the Moon. However, the fastest known speed belongs to that of light, at just over 1 billion km per hour or 300,000 km per second, also known as 1c. How close can we approach to 1c, and how would we do it? While the human speed record belongs to Apollo 10, we have built faster vehicles. One of the fastest human-made objects ever is the Helios 2 spacecraft at 252,792 km per hour. It achieved this tremendous speed when it came within 43.4 million kilometers of the Sun at the closest approach, using a gravitational assist to accelerate to these tremendous speeds. Both these records will be smashed, however, by a spacecraft set to launch in 2018. Called Solar Probe Plus, its mission is to investigate the Sun's outer corona. To do this, it will travel within a staggering 5.9 million kilometers from the surface of the Sun. Coming this close will cause it to reach speeds of 724,000 kilometers per hour, or 0.067% the speed of light. So how much faster could a human-manned spacecraft travel? When approaching speeds closer and closer to 1c, a surprising amount of bizarre activity starts to happen. The first is time dilation. At 10% the speed of light, or 0.1c, 1.01 days pass on Earth relative to 1 day on board the ship. The effect becomes more noticeable closer to the speed of light. At 0.5c, 1.15 days pass on Earth relative to 1 day on the ship. At 0.9c, 2.3 days pass on Earth, and at 0.999c, 22 days pass on Earth relative to 1 day on the ship. If keeping in the same millennium as an observer is an issue, keeping the ship down to below 90% the speed of light seems reasonable. However, another problem that arises even at 90% is the interstellar medium would become lethal to any travellers. A silicon grain in space that is only just 50 times thinner than a strand of hair would impact a ship travelling at 0.9c with the force of a high energy missile. Anything larger would likely completely obliterate the ship. At speeds even higher, the energy just becomes greater very fast. One final problem is that there is currently no known method to accelerate a large spacecraft to such speeds in the first place. Project Daedalus was a design for a fusion rocket capable of reaching up to 12% the speed of light. Faster spacecraft may be able to use antimatter, but getting to higher velocities and dealing with the problem of colliding into interstellar dust grains with the power of a high energy missile makes storing antimatter safely seem much more challenging. So what does this mean for how fast humans can actually travel through space? It is possible that we may discover a way to circumvent the light barrier through wormholes or an Alcubierre drive. However, if these are not feasible, no matter how advanced our technology becomes, then this will not stop us from colonizing the stars. It only means that our advance will be slowed, likely below 0.5c. Even at 0.1c, or 10% the speed of light, the entirety of the galaxy could still be explored and colonized within a million years. So, even if humans never get close to the speed of light, we will still conquer the vast horizons of our galaxy and likely all our close by neighbouring galaxies as well, even before the death of our own star. So what do you think about how fast humans will explore outer space? Leave a comment below with your thoughts, and thanks for watching.